Let me read the question 14 now. Diagram 10 shows a curve of a quadratic function fx equals to 2x squared plus hx minus 2k plus 5 such that h and k are constants. The curve has a minimum point at t. So as you can see here, this is the diagram 10. Okay, so let me read the question part A. Determine the range of values of x of fx more than 0. Okay, for the part B, prove that k more than 40 minus h square divided with 16. Okay, for the part C, using the method of completing the square, find the minimum value of function fx in terms of k. Okay, so by the time you finish read the whole question 14, so you should come up with an overall idea that this question comes from the quadratic function chapter. Okay, so take your time to solve this question and we will begin our discussion in a count of 5, 4, 3, 2, 1. Okay, let us begin our discussion for the question 14 part A, where we need to determine the range of values of x of fx more than 0. Okay, in order to find the range, okay, so we need to have two known roots over here. However, I have made a sketch based on the diagram 10. So we only have one known roots. In this case is negative 2. Okay, the other roots we don't know yet. So that's why I labeled here alpha symbol over here. So how are we going to find the second root? Okay, the question itself already gave us the hint that the axis of symmetry x is equals to negative 1 over 4. Okay, the axis of symmetry is actually a vertical straight line which divides the quadratic graph into two equal portions. Okay, so from here we can able to find the second root easily, guys. So from here, let me guide you. Okay, since x equals to negative 1 over 4 is the axis of symmetry. Okay, so the first step what we need to do is we need to find the distance from the axis of symmetry to negative 2 over here. So from here, what we do, negative 1 over 4, okay, we minus with negative 2. So from here you get your distance is 7 over 4. So once we get the distance from the axis of symmetry to negative 2, okay, it will be easy for us to find the distance from negative 1 over 4 to alpha, since it's intersect in the axis of symmetry and axis of symmetry divides the distance equally. Okay, so from here, hence alpha will be equals to negative 1 over 4 you plus with 7 over 4. So from here you get your alpha is equals to 6 over 4. Okay, so you simplify this, you get 3, simplify this you get 2, you get your alpha is equals to 3 over 2. Okay, so once we identify the two roots, which in this case is negative 2 and 3 over 2, now we can able to find the range of values of x of fx more than 0. Okay, so let me just draw a quick simple sketch. Okay, by the way, this question is involving the quadratic inequality, guys. Just wanted to confirm you. Okay, your first root over here is negative 2. So your second root is actually 3 over 2. So this is your basic quadratic graph. Okay, and then since we are having the range fx more than 0, so you shade the region outside the graph, outside. Okay, so from here we can get our answer. X is less than negative 2, so anything shaded over here will have a result of x less than -2, okay, or you can have a x value more than 3/2. So this is the two possible ranges that we can find for fx more than 0. Okay, so from here let me underline the solution. Okay, so we are done with the question 14 part A. Let us proceed to the question 14 part B now. Welcome back. In this question, we need to prove that k is more than 40 minus h squared divided with 16. For this particular question, we need to apply the discriminant concept within the quadratic function, guys. Okay, the discriminant concept, we have total of three possibilities, where you have b squared minus 4ac more than 0, which it will result in two distinct roots. B squared minus 4ac equals to 0, you will have two equal roots. Sometimes they will even say as one root. Whereas b squared minus 4ac less than 0, you will result in no real roots. Okay, in this case, since in the question gave us that it has two distinct roots, okay, the first is -2 and the second is 3/2 based on the solution that we found from the question 14 part A. Okay, so we're going to apply the discriminant b squared minus 4ac more than 0. Okay, in the question they already gave us the quadratic function 2x squared plus hx minus 2k plus with 5. So we're going to use that quadratic function and apply the discriminant b squared minus 4ac more than 0, and you're going to solve this question part B. So this is the overall idea on how we're going to solve this question. Okay, so I hope you clear on my explanation. So let us begin our working now. Okay, so since fx equals to 2x squared plus with hx minus with 2k plus with 5 has two distinct roots, okay, so from here we're going to apply the rule b squared minus 4ac more than 0. Okay, so from here we need to identify which is the coefficient a, b and c respectively. So let us do it together. Okay, the coefficient a is actually 2 in this case. Okay, so coefficient b is actually h. The coefficient c is actually this whole expression -2k plus with 5. Okay, so I hope you guys are clear. So let us move on to the next step. So let us substitute all the respective coefficient into this equation. So from here, h squared minus with 4 times with 2, okay, times with -2k plus with 5 more than 0. Okay, so from here, -4 we times with 2 first, and then that answer we later on times with this -2k plus with 5. Okay, let us do it one by one. So from here, h squared minus 8, okay, and then times with -2k plus with 5 more than 0. Okay, now this -8 you times in. So from here you get h squared plus with 16k minus with 40 more than 0. Okay, so from here, since we need to prove that the equation k in terms of h, so we let the k in the left hand side and the rest we move it to the right hand side. So I hope you understand what I mean, guys. Okay, so from here 16k is more than k, and then 40 minus h squared. So this -40 become positive, so this positive h squared become -h squared. So 16k more than 40 minus h squared. So from here to get k, what you do, 40 minus h squared you divide with 16. So from here 40 minus h squared divide with 16, and there you go. We have already proved that k is actually more than 40 minus h squared divide with 16 by using the discriminant b squared minus 4ac more than 0 formula. Okay, so let me underline the solution for the question 14 part B. Okay, so from here, let us proceed our discussion for the question 14c now. Welcome back. In this question, we need to find the minimum value of function fx in terms of k by using the method of completing the square. Okay, one thing you should know, guys, in quadratic function, we have the general form fx equals to ax square plus bx plus c, which can be determined by completing the square method. Okay, by using the completing the square method, we can express this ax square plus bx plus c in the form of a in a bracket x plus b close bracket square plus with cube. Okay, so in this question, we're going to use the fx equals to 2x square plus with hx minus 2k plus with 5. So we're going to express in terms of the general form a in a bracket x plus b square plus with cube. So this is the general form. But then since we are interested in the minimum value of function fx, so we only interested in the q value. Okay, so still don't understand? Okay, no problem. Okay, let me guide you one by one. So from here, this is the quadratic function fx equals to 2x squared plus with hx minus with 2k plus with 5. Okay, so the first step, what you need to do is check whether your coefficient a is actually 1 or not. If your coefficient a is 1, okay, there is no problem. But if your coefficient a has a value other than 1, that means you need to factor out the whole quadratic function by its coefficient. So in this case, since you have your coefficient a is 2, so you need to factor out the whole quadratic function by 2. So let us factor out the 2. Okay, and let me put a square bracket here. So from here you have x squared plus with h over 2 x, excuse me, minus with 2k plus with 5 divided with 2, close bracket. Okay, since this negative 2k plus with 5 we consider as a c, so that's why we combine them together. Okay, so from here, let us proceed to the next step. Okay, so in this step, we are going to apply the completing the square method. So how are we going to apply the completing the square method? So let me show you. Okay, the 2 square bracket. Okay, over here, still the same x square. Okay, the second one, h over 2x. Okay, still the same. Okay, over here, there is going to be a slight change. Okay, what we're going to do is, we're going to divide the coefficient of h over 2, divide with 2, and then we're going to square them. The coefficient, guys, okay, the coefficient of h over 2 divided with 2 is actually h over 4. Okay, and then we're going to square them. Okay, since this is a completing the square, so we need to balance them with a plus and a minus. Okay, when you have plus in a bracket h over 4 square, so it is important to have a minus as well to balance the equation. H over 4 square. Okay, and then you continue with minus 2k plus with 5 divided with 2, close, square bracket. Okay, so I hope you understand my working till now. So from here, proceed to the next step of working. Okay, for the next step, what you're going to do is this x square plus with h over 2x plus with h over 4 square. So we're going to reduce it into a quadratic factor of x plus with h over 4 square. So why we are doing that? So that quadratic factor will be useful for us to find the axis of symmetry, guys. So that is the reason we are reducing this expression into a quadratic factor of x plus with h over 4 square. Okay, if you don't believe me, this x plus with h over 4 square, when you try to expand it, you will get back this original expression again, which is x square plus with h over 2x plus with h over 4 square. Okay, so from here to okay, in a square bracket, okay, and then you from here you write the quadratic factor x plus with h over 4 square minus with h square over 16, okay, so you expand this, okay, and then minus with 2k plus with 5 divide with 2. Okay, so from here this negative h square over 16 minus 2k plus 5 divided with 2, we combine them together, okay, by times the denominator by 8 and the numerator by 8 as well. Okay, so from here fx equals to 2 in a bracket x plus with h over 4 square minus with h square, so negative 2k times with 8 you get is negative 16k, 5 times with 8 you get is 40, okay, and then you divide with 16, okay, close square bracket. Okay, so once you have done everything, okay, the next step, which most of the students tend to omit this step, which is you need to times the 2 back into this equation, guys, okay, the whole equation. So from here when you times the 2 back into the equation, from here you'll have 2 in a bracket x plus with h over 4 square minus with h square minus with 16k plus with 40 over 8. Okay, so now you can remove the square bracket, so this will be your general form in terms of a in a bracket x plus p square plus with q. So this x plus p in this case is x plus with h over 4, and in this case our q is this following expression. Okay, however, the first step what we need to do is we need to compare the axis of symmetry given by the question to the axis of symmetry that we obtained from this equation. Okay, so the axis of symmetry given by the question is x equals to negative 1 over 4. So from here, how to find the axis of symmetry? Very simple. Okay, so from here x plus with h over 4 equals to 0. So from here you get x equals to negative h over 4. Okay, so from here comparison. So from here negative h over 4 equals to negative 1 over 4. Therefore you get your h is equals to 1. Okay, so far so good. For the next step, what you're going to do is we are interested to find the minimum value. So minimum value is this, guys, and you already know that value of h is actually equals to 1. So we can substitute this one into this following q expression over here. Okay, so from here to find minimum value, okay, so from here equals to negative 1 square minus 16k plus with 40 over 8. So from here you get is negative 1 minus 16k plus 40 over 8. So from here you get your answer 39 minus 16k over 8. Okay, so this is your final answer. Okay, by the way, for some student you can ask me the answer scheme show that 39 over 8 minus with 2k is actually the same as this expression, guys. The only difference is this is combined two fraction. The answer given by the answer scheme is actually two separated term. Okay, so when you split this, you can form 39 over 8 minus with 2k. But since we are combining it into one single fraction, that's why you have 39 minus 16k over 8. It's actually the same, guys. Okay, so your answer is considered correct if you leave it your answer in this way. Okay, so that is all for the step-by-step working and solution for the question 14. I hope you find this video useful. If you like this video, please give a thumbs up. If you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming Math tutorial videos in the future. And please share this video to your friends. Thank you everyone for your support, and I'll see you in the next video.